so the experiment going on right now is the aspirin synthesis. It's a one-step synthesis starting from salicylic acid. And we're going to use acetic anhydride as our acylating reagent. So we've got acetic anhydride here. We want to add 5 mils of acetic anhydride to our salicylic acid. So I've already weighed out the salicylic acid and posted the amount that was weighed out for you. That's 2.072 grams, but do show the calculation in going from millimoles. It's 15 millimoles to grams of salicylic acid. And then I'm just going to simply add my acetic anhydride. I've got about 5 milliliters here to my Erlenmeyer flask. Okay. And I'm just going to give this a little swirl. And the last step is to add a few drops because this is acid catalyzed. We're going to add about 3 to 4 drops of sulfuric acid. And this is concentrated, so I've got it in this bucket here. We don't need a lot, right? So if it's catalytic, that means it's going to turn over in the reaction. And we just need a few drops of it to get that reaction to go. Set that aside. And I'm just going to give this another little swirl here. And what we want to do is to heat this reaction. We're just going to gently warm it to about 50 degrees Celsius just to get that salicylic acid into solution. And so I've got some water here heating on a hot plate, starting to get a little bit warm. Once I do that, we want to see this solid hopefully dissolve and then crystallize back out. So we won't heat this very long, maybe for about 6 minutes or so, but I'll keep you guys posted on that. Alright, so we've let this heat for about 6 minutes now, and I've taken out my thermometer just so I have room for my flask. But this was about 50 degrees Celsius. It's nice and warm, and it's allowed for our solid salicylic acid to dissolve, which means that now it can go into solution and react with our acetic anhydride. And so what we're going to do is just let this cool off to the side, and hopefully we'll see some nice crystallization occurring. Alright, so now our initial crude product is fairly dry, but it doesn't have to get completely dry because we're just going to add an aqueous solution of some sodium bicarbonate anyways, so it's going to get wet again, but it looks pretty good. So we're going to cut off the vacuum and we're going to put this into a beaker and start our purification. Alright, so I've scraped out what I could out of the beaker funnel. You see there's some material still left behind, but it's pretty small. But yes, there is a little bit of transfer loss. But mostly what we have in here is our product. Now, in the procedure it says we need to do a separation, a purification of our crude product. And we're going to do that with some 5% sodium bicarbonate solution. It's a solution in water. So we're going to add about 25 milliliters of that into our beaker. And what you guys want to think about during this step is what are we separating or purifying our aspirin product from? Like what is it being separated away from, right? So let's see what happens when we add our bicarbonate. So you see it's kind of fizzing, bubbling up. I'm going to mix it up as well. Now, sodium bicarbonate is a base, and you can look at the the structure of aspirin and see that it still has its carboxylic acid functionality intact. So you can imagine what this reaction will be, will look like. So you could create that scheme. I believe that's one of your questions in either your pre-lab or your post-lab. But I'm just going to kind of let this settle and react a little bit. You see it's still kind of fizzling and bubbling a little bit, which means there's a bit of a reaction going on still. And you can swirl it also. But you notice there's some solid here that's not dissolving, okay? So, if what's reacting is the sodium bicarbonate is with the carboxylic acid, then obviously this solid that's left behind, which is not reacting, probably does not have that carboxylic acid functionality on it. So you want to kind of think about what this product could be. What are we separating this away from? It doesn't have a carboxylic acid on it. All right. So whatever does not dissolve, you're going to filter. We're just going to, consider waste. We're going to filter that away using a filter funnel, just by using a glass funnel. So we've got our glass funnel. I'm going to get some filter paper to fold up into our glass funnel. The white solid that is not dissolving will remain up at the top, and our solution, our basic solution, will run down to the bottom. And then we'll add some acid to that in order to get our aspirin back intact. So I'll just do this. And I'll pour my solution inside the funnel. And it may come out pretty slow. But it's our aspirin that's now in this aqueous solution. We've manipulated its carboxylic acid functionality to get it away from this impurity. So I've just finished filtering off that impurity by gravity filtration. So now we have our nice clear solution here that has our aspirin product. And it's a basic solution. Remember, we added that 5% sodium bicarbonate. So we want to reprotonate our carboxylate and get our neutral aspirin graph. So we need an acid, and we're going to use 3 molar hydrochloric acid for this. So we're going to slowly add it. We know that acid-base reactions can be vigorous, so we want to be kind of careful about it. See, we already have lots of bubbling and fizzing. And when you protonate sodium bicarbonate, think about what kind of gas that we're forming, which is coming off of this. What is that? Okay. So I've added all 8 milliliters at this point, and we want to give it a stir. I'm going to use my glass stirring rod. Make sure our pH is below 3. So I've got my pH paper, And red is acidic towards 1 and 2. So I'm going to pre-wet this pH paper before I test my solution. So if I just give it a little tap, you see that it turns bright red. Okay. Now you can look on the scale in your pH roll and see that that will lend itself to a pH of around 1 or 2. So we are good to go. And we're going to cool this solution just to make sure we maximize all the solid coming out of that solution, precipitating out, and then we'll filter this off using vacuum filtration. So this has been cooling for a little bit. I just took it out, and you see we've got lots of white solid in there, almost crystalline-like. So we're going to go ahead and separate this using our vacuum filtration. I didn't switch out my filter flask, but everything we want should stay on top. So I'm going to start my back line. You can hear it hissing. And we of course want to wet our filter paper before we filter to make sure all holes are covered. See that there are some holes that aren't covered. So I'm actually going to turn my vacuum off. Release that pressure and kind of move this over so that everything is nice and secure. Start my back line. So everything looks good. Just move this little slide. To rinse out our flask. Make sure we get a nice high recovery. To rinse your stirring rod, and we'll let that dry for a little bit. We're going to take a little bit of this sample and put it in a test tube, which will be our technically separated sample. And I'll go over this in a little bit, but when we do our iron analysis. But this sample here, this first one, is going to be our sample right after the reaction. So it's essentially like our crude sample, or sample of the crude product. This one is going to be the one we just filtered off. This is going to be the one where we separated out that unknown impurity. And then this last one will be used, this last test will be for our recrystallized sample. The first one will be for our control, so we can see what the iron should do when it tests for phenols. Take a little bit of this sample and put it in a test tube, which will be our technically separated sample. And I'll go over this in a little bit, but when we do our iron analysis. But this sample here, this first one, is going to be our sample right after the reaction. So it's essentially like our crude sample, or sample of the crude product. This one is going to be the one we just filtered off. This is going to be the one where we separated out that unknown impurity. And then this last one will be used, this last test will be for our recrystallized sample. The first one will be for our control, so we can see what the iron should do when it tests for phenols. So now we need to recrystallize our white powder, our technically separated aspirin, but we want to purify it. So we're going to do that by recrystallization. Remember, that's one of our organic 1 techniques, and we'll hopefully have some nice pretty white crystals after this, crystalline solid. So we're going to do this from ethanol. Okay, so remember the properties of our recrystallization solvent is that our solid needs to be soluble at high temperatures, but insoluble at low temperatures. Okay, so we want to be able to heat up our ethanol, add it to our solid, and at high temperatures, everything dissolves, impurities included, so that any impurities that are trapped in that solid can come out. And then we want our crystals to slowly form as it cools down back to room temperature. And then of course we'll ice it once it gets to room temperature so that we can maximize crystal recovery. Think about what happens as temperature decreases, what happens to the solubility of your product. So I'm just going to put some ethanol in a beaker, and we're going to get that heating. We want to be very careful because we know that ethanol from our MSDS, our ethanol is flammable. Okay. I've also got some water heating because I want to eventually add in twice the amount of water to our dissolved product in ethanol, and that way we can encourage that crystallization. It's useful to use one of these pipettes to help in that process, to help add either water or our ethanol. So I'm just going to put these guys on the hot plate so they can heat up. I like to do recrystallizations in Erlenmeyer flasks. I feel like it helps you when you want to mix so that your solution doesn't splash out. So I'm going to add this separated aspirin product. Okay. And it says a minimum amount of boiling ethanol, but I don't know how much that is, and it might vary from person to person because everyone's going to end up with a different amount of solid, which will require either more or less ethanol to dissolve it. So before I put this solid on the hot plate, I definitely want to add a little bit of ethanol to my solid, because you never want to put just dry solid on your hot plate. You don't want to scorch your product or decompose it. Okay, so I've just got a little base of ethanol in there. It's kind of already dissolved a little bit, right? But that's okay. I'm just going to keep adding. Okay, I'm going to let that heat up. You can see there's some crystals that have not dissolved. We're going to let that heat, and then I'm going to add, I believe it's equal amount of water to this solution. You're starting to see bubbles.